Hello friends, welcome to my channel. Today we are going to discuss some practice problem on heterocyclic chemistry. So the problem which we will discuss today will be pretty much similar like CSIR NET or GATE exams problem, and some will be of course included have previously appeared in CSIR NET exams, or some will be some similar types or a new reaction. So I have chosen accordingly those problems which may appear in CSIR NET or GATE exam. So let's start. So this problem is very common in CSIR NET or GATE exams, have appeared many times in both the exam or even in IIT JAM also. So at first the acidic anhydride reacts with substitute N-oxide. So what happens that the O- of the N-oxide attacks the carbonyl of acidic anhydride. So oxygen of N-oxide just acetylated and acetic acid cleaves as a leaving group. So we get this. So now this CH3 alpha to the N-oxide is significantly acidic. So the acetate which cleaved in the first step of the reaction just takes up the proton, and this electron goes back, this ring electron goes here, this goes here, and the negative charge of the N-oxide is satisfied. So we get this. Now what happens in the next step? Water molecule was there, so water molecule just attacks in this C double bond C. So this one goes here, this one goes here, this one comes to nitrogen, as this is acetate moiety, this is a good leaving group, so this cleaves. So we get this as a product. Sorry, there is a methyl. So this will be a product. This is have appeared previously many times in exams. This is also a very common question. So what happened? The chloroform converted into a substitute carbene, chlorine substitute carbene in presence of the KOH as a base. So that's generate CCl2 as a carbene. Now in PYROLE there is C double bond C. So the addition of carbene occurs. So we get this type of intermediate. So after that electrocyclic ring opening occurs because this is very strained, and there is chlorine obviously, which is very good leaving group. So this electron goes here, this goes here, and this bond just cleaves, joins here, and this one of the chlorine cleaves. So what we get? This is like this. This is a 6-membered ring. 1, 2, 3, 4, 5, 6. So just if I write correctly, that will be a chlorine substrate PYRIDINE. This is the answer. This is also very common question. It is in heterocyclic chemistry but haven't appeared yet in CSIR NET or GATE exam. So I have chosen this example. So at first what happens, as there is a carbonyl attached to this FURAN, what happens, this one goes here, this one comes here, this one goes here, this goes here. So this type of electron flow could be expected. So now what happens, there is ammonia in the reaction medium, there is positive charge, so that attacks at this carbon, this O- clips, so we get NH2 now, and it will be put on the alcohol simultaneously. So it will again tautomerized again in previous form, so we get this. Now one of the lone pair of the nitrogen pushes back these clips, so now we get, oh, there is a double bond. Now we get double bonded NH, that is it, and this is 3, and we just put on it. Now I am just taking this bond into here just for simplification, so I get just writing it like this, the simplicity for the drawing. So now what happens, from this center and this carbon center, condensation reaction takes place. So what happens, that after that there is double bond was there. This is OH after nucleophilic attack. There is also OH. There is also hydrogen also. So now this one, if came here, the OH takes as a leaving group. So now what we get, if we write correctly, it will generate a substrate pyridine. There is a CH3, there is a OH. Okay, the driving force was just to retain the atomicity. Okay, this is our product. So this is substitute indole which has reacted with alpha beta unsaturated carbonyl. So what we expect, that from the indole nitrogen, this lone pair comes here, this bond just attacks at the unsaturated carbon, that bond goes here, the carbonyl double bond breaks. So what we get, we will get there was 2-methyl, and after that this carbon goes here, this again is the bond. Okay, so after that it again goes here, this pulls back, takes photon from the reaction medium, so we get now this. Now here what happens, that the main trigger, there is some enol content from this COMe group. So if we write the enol form of that carbonyl, so that will lead to a cyclization reaction, and that will again be the driving force also for the cyclization. So what we can get, that is enol of this COMe moiety. Okay, so now if this enol breaks, so that electron goes here, electron pair, and that nitrogen will get back its electron. So we get a cyclized product. Sorry, it will be a 6-membered ring with ketone, and there will be 2 methyl. Is again 1 methyl. This will be the product. So now this example has previously appeared in CSIR exam. So this is the N-oxide. So now what happens at the pH MgPr, the pH acts as a nucleophile. So that attacks at the alpha and the 2 position of the N-oxide. So we get pH. Now nitrogen gets back its electron. So we get this as a product. After that, reaction is heated up. So for this, the electrocyclic ring opening occurs. So this electron goes here, this goes here, this comes here. So we get pH double bond. This double bond is double bond N minus. And simultaneously, next reagent was acetic anhydride. So that's just acetylates this O minus. So we get as a product, acetylated product. After that, again, heterocyclic ring closure starts. So again, get the cyclized product. Now there is again a hydrogen. This bond pair comes here, and now the acetate is a good leaving group, converted into a good leaving group. So it just cleaves. So we get this as our product. So this is our next reaction, where this is one of the techniques to create carbonyl from the halide. So what happens, this O minus attacks at the benzyl position and just cleaves the CBr bond. So we get so now what happens in the reaction medium, they are used a base, okay, sufficiently strong base, which picks up this proton from each side. So what happens, base picks up this proton, this double bond goes here, this bond pair goes to nitrogen, as this is electron deficient, so the flow of electron is well satisfied. So we get carbonyl from benzylic halide. Okay, this could also come as one of the steps in consecutive reactions of scheme which comes at CSIR NET or GATE exam. So this example previously came in CSIR NET exams. So I am just again writing it. So the N-oxide, pyridine N-oxide, just the O minus attacks the carbonyl of benzoyl chloride. So we get this as product. Now in the medium there is Cl, now which can attack either of the position, it as ortho and can also para. The flow of electron will be identical. So if it acts at the para position, then this electron goes here, this electron goes here, and again if it acts as ortho, then again similar thing. So I am showing the para attack. Now HBr eliminated from here, this one goes here, this one goes here, and phenyl acetate is good leaving group, so it cleaves. So we get chlorine substrate pyridine. And also from the ortho attack we can get similarly ortho substrate pyridine. So now instead of pyridine, here is quinoline has been taken. but the course of reaction for pyridine or quinoline will be similar for this type of reagents. So here what happens, at first in presence of glycerol acetic acid solvent and H2O2 as an oxidant, quinoline will be oxidized, so we get N-oxide of quinoline, which will have similar course of reaction to that of pyridine. So after the nitration occurs, so nitration will be at the para position. You know, for the N-oxide reactions, if the electrophile will be at para position, then that will be stabilize the sigma complex. And after that, P3 added, which just attacks this O minus of N-oxide. And after that, this O minus PO-PH3 will be cleaved. The N-oxide will be freed up. So we will getting ended up like this nitro substitute pyridine. This is a way of getting this para substitute, this 4 substitute quinoline. Because if quinoline is attacked with nitration, then at the 4 position that will not substituted. So making that N-oxide and again getting back the quinoline, we can substitute at the 4 position the nitrate. Now substitute indole is treated with bromine. We know that there is nitrogen attacks here. This goes to one of the BR. If we take BR as like this, so this BR clips, we get now in the reaction medium there is Br, so that takes up this alpha position proton. So this electron goes here, this electron gets back to this indole nitrogen. So we get then after that, so now water was the next reagent which will attack this C double bond C, double bond goes here and bromine being a good leaving group that cleaves. So we get this as a product. This is our next example. So what happens, the O minus attacks the phosphorus, and then Cn minus cleaves. So we get product. Now Cn minus is just the nucleophile which attacks either of the position at para position or at ortho position. So if it attacks here, so then one goes here, this one goes to the nitrogen, positively charged nitrogen. So we get for para attack we get this. So this becomes a really good leaving group, this phosphate moiety. So after that what happens, that this hydrogen eliminates, this goes here, this bond goes here, this cleaves. So we get 4 substitute pyridine, and again from the ortho attack we get similarly this as a product. So these are the few examples of heterocyclic chemistry, which few examples previously appeared in CSIR net or GATE exam, and few are new, which I thought that may come in future in CSIR net or GATE exam and placed as a practice problem. So in the comment box let me know that if you want similar types of more practice problems or not, or if you want to know some properties of like indole, pyridine or FURAN, or like PYROLE, more characteristic reactions or synthesis type, if you want videos on those things, so synthesis or characteristics or some reactions on them. If you want that, please write in the comment box and let me know. Okay, thank you.